right, so we're about to take a look at Chapter 7. We're going to take a look at two sections, 7.1, which is about something called the Law of Sines, and 7.3, which is about the Law of Cosines. Okay. Before we do that, I want to just address how we're pacing things at the end of the semester. So this is spring 2020. I'll probably keep these videos up for people to review for other semesters. So what I'm about to say is specific to spring 2020. We basically spent a day and a half doing each of the three sections from Chapter 6. We're now going to spend a day and a half doing two sections from Chapter 7. Chapter 6 is way more important. Chapter 6 is about inverse trig and solving trig equations. Those are skills you're going to need with you in pre-calculus and in calculus, and you're going to be solving trig equations on a regular basis. And you're going to be using inverse trig not quite as often as you'll be solving trig equations, but with some good regularity as you go through pre-calculus and calculus. So those skills are really, really important, and that's why I slowed things down a little bit and spent a little bit more time on those. Okay. Not saying that these aren't important. They are, but they're not skills that you're going to use as regularly as you make your way through the calculus sequence. And so I wanted to spend more time on the skills that you're going to be using more often. I will guarantee there will be one question on your final exam that deals with law of sines and or law of cosines. But my emphasis is going to be that you simply know how to use those things. I'm not concerned that you spend a lot of time saying, if I have this information, I'm going to use law of sines. And if I have that information, I'm going to use law of cosines. I'm going to help you out with that just because we're going through this a little bit quickly at the end of the semester, and I don't want to overwhelm you with too much. So on the exam, if I'm asking you to do something, I would be very specific with my instructions. I would say, use the law of sines to do this, or use the law of cosines to do this. So you don't need to spend a lot of time. I familiarize yourself with it, but you don't need to spend a lot of time saying, when do I use which one? You just need to know how to use each one. Okay, so both of these are going to help us in solving a triangle. So let's remember, to solve a triangle means to find all angle measures. So that would be all three measures of all three angles. And find all side lengths. And we did this earlier this semester, but when we did it earlier this semester, we only solved right triangles. For that, we were able to just use SOHCAHTOA and the definition of our trig functions. Now, we're going to be solving oblique triangles. And those are just triangles that have no right angle. So if it's not a right triangle, it's an oblique triangle. It could be an obtuse triangle where one of the angles is obtuse. It could be acute where all three angles are acute. As long as none of them is a right angle, we call it an oblique triangle. Okay. Now, if I'm going to solve an oblique triangle, I'm going to need to use the law of sines and or the law of cosines. Okay. Now, they're true even if I have a right triangle. So I could use law of sines and law of cosines with a right triangle. I just don't usually need to because I can just use the definitions of my trig functions. But the law of sines and the law of cosines are true regardless of what sort of triangle you have. Okay, before I state what they are, let me just remind you of the convention for how we label the sides and the angles of a triangle. If I label my angles with capital letters, so I call the angles angle A, angle B, and angle C, I can label the sides with lowercase letters, where I would put A as the side that's opposite angle A. Lowercase b, that's going to be the side that's opposite angle B, and lowercase c will be the side that's opposite angle C. And that's true for any sort of a triangle. So I could have A, B, C. This would be A, B, and C. That almost looks like it's a right angle, and I didn't want it to look like that. So let's make it a little more obvious. There we go. Okay, so this is an acute angle where every one of these angles is acute. This would be an obtuse where angle C obviously is an obtuse angle. Okay. All right. So I have the law of sines, which says this. In any triangle, this ratio, side length A divided by the sine of angle A, is the same as the ratio of side length B to the sine of angle B. And that's the same as the ratio of side length C over the sine of angle C. Okay. So that is what we call the law of sines. We're going to be using this if we know two sides and one angle. I'm sorry, I said that backwards. We're going to be using this if we know two angles and one side. Okay. Now again, on the final exam, at least for spring 2020, I will tell you when to use law of sines. But it's kind of nice to just know that's the general rule. If I know two angles and one side, I'm going to be using law of sines. Okay. Law of cosines says c squared, that's this side length squared, is equal to a squared plus b squared minus 2ab cosine of c. Okay. So it sort of singles out one of the sides. Here I've written the version where we've singled out side C. And I'm saying that side length squared is this side length squared plus that side length squared minus 2 times this side times that side times cosine of the angle C. So notice the cosine of the angle is the angle where if C was sort of the side that I singled out here so that we've solved for C squared, we're using cosine of angle C, the angle that side C is opposite. Okay. Notice, if I didn't have this term, that looks kind of like the Pythagorean theorem. That's what I would get if angle C was a 90-degree angle, if C was the hypotenuse of a right triangle. And notice, if C is a right angle, if it's 90 degrees, cosine of 90 degrees is 0, and so this term drops out. So basically, this is a bigger statement that includes the Pythagorean theorem in the case that C is 90, but gives me a relationship between the angles and the sides that I have here. Okay. Now, there are three versions of it. This one sort of singles out side C. I could single out side A. Then I would say a squared is b squared plus c squared, the sum of the other two sides squared, minus 2bc times cosine. Now it would be cosine of A, so that the angle here goes with the side that I've singled out. And then I can say b squared is a squared plus c squared minus 2ac cosine of b. Those are the three versions that we have for the law of cosines. Okay. Now, I'm going to use the law of cosines if we know all three sides, or we know two sides and the angle between them. Okay. So law of sines is when I know two angles and one side. Law of cosines, all three sides or two sides and the angle between them. Now you may have noticed we're skipping section 7.2. 7.2 is what's called the ambiguous case of the law of sines. That would be if I knew two sides and an angle, but the angle isn't the angle between those two sides. So for example, I would use law of cosines if I knew sides A and B and angle C. That's the angle between those. If I knew sides A and B and angle A, that doesn't quite match this. That's what's covered in 7.2. Okay. In 7.2, we call it the ambiguous case because for some combinations of numbers, you don't get any triangles at all. For other combinations of numbers, you get one triangle. For others, you get two triangles. It's kind of a fun puzzle to actually figure out how many triangles can fit the data that you're given, but it's a little more complicated. And so I'm just going to focus on the simpler cases that are covered in 7.1 and 7.3. Okay. So this is our statement of the law of sines. It's actually labeled, that's the law of sines. These are the three different versions that we have for the law of cosines. And I've sort of given you a criteria for when we use which one, although you know on the final exam I'm going to be nice and say use this law to do this thing. Okay, so I've sort of stated what both of these laws are. What we're going to do in the next few videos is work through some examples of law of sines, and that way you'll be able to complete the homework for 7.1, and then we'll wrap up the videos for Chapter 7 with some examples using the law of cosines, so that then you'll be able to complete the homework for 7.3. Okay, that's our plan for the rest of the semester.